Good afternoon. My name is Scott Tayo, and I'm the head of the School of Engineering and Information Technology at the University of New South Wales, Canberra. I'm here today recording in August of 2020 as we deal with the COVID-19 situation and have a virtual open day this year for the first time in our history. And the presentations you're going to have access to in today's virtual open day is a combination of material that I'm recording now, along with snapshots from last year's live open day that we did in front of an audience with live questions and answers and other people participating. I'm going to be recording all the information today, but my colleague, Associate Professor Kathryn Kasmarik, will be on in the live segment that you'll hear in the other portion of the presentation that describes our academic programs. Here in the School of Engineering and Information Technology, we have the mission of fostering Australia's future decision makers and advancing the technologies that will shape our region's defense and security future. We're a very special engineering institution in the country, and that we have a very dedicated mission around servicing the needs of the future of Australian defense and security. Before I begin, I would like to acknowledge the traditional custodians of the land, the Ngunnawal people. The Ngunnawal people are part of the ACT's community, both past and present. And we here at UNSW Canberra are committed to having greater involvement from the traditional custodians in the things we do going into the future, recognizing that we haven't always had the participation from those groups in the past that we might have wished that we would have. In the rest of today's presentation, I'm first going to talk to you about why it is that you want to become an engineer. And then I'm going to discuss how you're going to learn about becoming an engineer at UNSW Canberra by going through each of our degree programs. After you've heard about our degree programs, we'll talk about what's special about our particular campus, the university life, and what students do on a day-to-day basis. And then the presentation will finish with instructions on how to apply to UNSW Canberra at ADFA. Over the last couple of years here in the School of Engineering and IT, what we often will call SEEIT, we've really started to focus on our prime deliverable, which is the people that go through our organization. Now, in large part, that's the students like you who are going to come in here, study for a few years, and then go out into the workforce, into defense or other places. It's also the research students who are working on their PhD degrees. It's also the staff, professional staff, technical staff, and of course the academic staff who will come here, spend a portion of their lives, contribute, and then move on. What we're trying to do in the school is to create a unique and engaging, supportive learning environment where people choose to come if they want to contribute to the future of Australia's defense and security. They come here because we have world-leading research programs that inform that outstanding educational experience that we deliver throughout all levels of the educational endeavor. But we have a key vision here, and that is that Australia's future leaders begin their educational journeys with us, and then they return throughout their careers to become the best in their chosen fields. So let's now talk about what it is that engineers do and why you want to become an engineer. And normally at this point in the presentation, I'd ask some questions of the audience about what it is they think that engineers do for a living. And we always get different sorts of answers. We get people that say, oh, they design things, they build things, they service equipment throughout its lifetime, and all of those things are true. But I always like to say what engineers do is they provide the technologies that support a future knowledge economy. So it's very much about creating opportunity, economic, technological, fun opportunities for the people of this country, our region, and the world going forward. And what I want you to spend a little bit of time doing is thinking about your future as an engineer and how coming here to UNSW Canberra can help set you up for that future. How do engineers go about shaping the future? Well, they create new and innovative technologies, new ways of doing old things. Here we see a tractor plowing a grain field somewhere probably out in Western Australia, and there's one noticeable thing missing from this tractor, and that's the farmer. Hopefully the farmer's inside watching the AFL. In this particular case, he's got an autonomous tractor that's out working in the fields. These sorts of technological innovations have taken the traditional industries that are important for this country, like farming, like mining, and made them more productive and more able to service the needs of our country and the world. In addition to developing new technologies that affect how we do our work and how we live our day-to-day lives, engineering also shapes the world around us, creating new cities, new opportunities, looking after our happiness, our well-being, and our health and safety. Engineers enable this through new ideas and new ways of thinking about classic problems of living. When you come and study any program in a university, but specifically when you study a professional program like information technology or engineering, it's partially about the specific skills that you learn while you're studying, but it's very much more about a set of problem-solving skills that you're going to be able to take out into your future as a practicing engineer. Yes, many of the things that you're going to learn about while you're studying are going to be directly important to how you do your jobs on the first day when you walk out of your undergraduate degree. But many of the things that you're going to do throughout your career haven't even been thought of yet. And what we want to do here at the University of New South Wales, Canberra, is instill you with a set of skills that makes you a problem solver. We build on the foundation of what you're currently doing in school with your math and your physics. Here in university, you will learn a broad base of fundamental skills in your chosen discipline across the range of engineering and information technology specialties that we offer. And then you will take that foundation and go out into the world and make an impact in the applications where you choose to participate. I'm now going to hand over to the Deputy Head of School for Teaching for the School of Engineering and IT, Associate Professor Kathryn Kasmarik. And you're going to hear Kathryn talking to last year's open day with an audience in the room about each of our engineering and technology degree programs in the School of Engineering and IT.
Hello, my name's Kathryn. I'm a computer scientist, and my role today is to introduce you to the different programs that we offer here. So Scott has just told you about your future as an engineer if you study here. My role is to take one step back and have a look at the things that you will study to prepare you for that future. So this is a summary slide of our programs in undergraduate education. So undergraduate programs are taken by students who might come straight out of school, or they might be students who've come out of school, they've gone and done a job for a few years, so they might have been in the Defence Force for a few years, and then been selected or decided to come back here and study their first degree. So the next couple of slides, I'm going to have a look at each of these programs and tell you a bit about each of the different types of engineering to give you an idea of what you might be interested in. So we have programs across technology, across engineering, so aeronautical engineering, mechanical, civil, electrical, and also computer science. These programs come in two levels. So we have our normal stream level, which are the ones you see on the screen, and we also have a talented student program called the Chief of Defence Force program. So this is something that I'm not going to talk in detail about today. This is our postgraduate suite of programs. So these programs are typically the second or subsequent degree that people might take. And they take them for a number of reasons. They might wish to have a skill change in their career, or they might wish to skill up in their particular area of interest, or it might be to prepare for a research degree afterwards. Today I'm going to focus primarily on the undergraduate programs, which would be your first degree that you might take. So the first of these I'm going to talk about is the mechanical engineering degree. So all our engineering degrees are 4-year programs. Mechanical engineering is about machines. So it's about developing, designing, maintaining, improving the machines that are used in our everyday lives. These can be anything. It can be as simple as a lawnmower or a hedge trimmer, or it might be a robot or a space vehicle, or it might be something from the Defence Forces. It might be a tank or a weapon system. People who study mechanical engineering can end up in small businesses, they can end up in large businesses, they might be doing design, they might be doing actual construction or maintenance kinds of tasks. So if you study mechanical engineering, what will you actually study? So the first things that you'll come here and study are things like maths and physics and a bit of chemistry. Because this gives the skills that underlie the rest of the program. You'll also study some computer science and cybersecurity. So every student who comes through this campus will study some cybersecurity because we believe this is part of the foundation for future engineering. So from these general topics, you'll then go on to study a bunch of mechanical engineer specific topics. So things like fluid dynamics, structures, and heat transfer. So why all of these things? So machines can be standing machines, they can be moving machines. As soon as you have moving parts on things, you can have friction and heat transfer. And all of these things are important for making sure that the machine can run efficiently. Likewise, the machines might have pipes, they might have hydraulics, they might have lubricants. So understanding things like how fluids flow is an important part of building machines that can work properly. So all of these individual topics will come together to give you the technical skills to be a mechanical engineer. On the other side, there's also a bunch of non-technical skills that engineers need to learn. So engineers often work on very large projects, and large projects mean a lot of people and they mean long periods of time. And in order to get these projects to work well, project management skills are really important. So things like planning, resource management, and budgeting are really important for having a successful project. So these are the things that come together to create a mechanical engineering program. Mechanical engineers in defence are used within the Army, Navy and Marine engineers, in the electrical and mechanical engineering corps and in the armour corps. So there's a whole range of jobs that mechanical engineers will go into. What I actually have next is a video that was created by some of our mechanical engineers.
Colonists on the planet of Gondwana in the outer fringes of the Milky Way have suffered through years of catastrophes. Drought is now a serious threat and starvation is imminent unless water is found for their crops. Once again, they're turning to UNSW Canberra student engineers for help. But Gondwana colonists only want the most effective solutions. So they're pitting UNSW Canberra student engineers against each other in a battle of skill. Students will need to solve intricate challenges and show off their talents on a galactic scale before a winner can be chosen. Which team will reign supreme and help restore peace and tranquility back to the planet of Gondwana?
Our next program is aeronautical engineering. So this program is actually closely related to mechanical engineering. The difference is that we're now dealing with machines that can fly. So we're looking at still the same sorts of topics that are covered in a mechanical engineering program. So still your physics and your maths and so on, your computer science. But now we're looking also heat, fluids, aerodynamics, fundamentals of flight. So all of the different components that you need to design, build and maintain machines that can fly. These sorts of skills are valuable in industries such as space industry, airlines, and the civil and military aerospace organisations. In defence, they lead to careers in the Army, Navy and Air Force. So all of our services have flight vehicles. So they're roles with fixed and rotary wing vehicles, both with personnel and without personnel. We then have, so I've just talked to you about the 2 4-year programs. We then have a 3-year tech program, one in aeronautical engineering and one in aviation. So our aeronautical engineering program is similar to the engineering program, but it's a 3-year version. So rather than having the last 4th year, which is a big project year, there's a smaller project that runs in 3rd year. And I'm going to talk a bit more about the project work a little bit later on as well. We have BTEC Aero and a BTEC Aviation. So aeronautical engineering is looking at things like the design and maintenance of flight vehicles. Aviation is looking at things like actually flying those vehicles safely. So for example, what are the human factors that are involved in flight? How do we achieve safety in a system that has both machines and people? How do we do things like air traffic management? So it's a different flavour of aero engineering. We then have electrical engineering, also a 4-year degree, and this is looking at the design, build, maintenance of small electronic systems, electronic and computational systems. So this program is different to the mechanical and aeronautical programs in the sense that the focus is now on maths and computing. So you'll do more computing in an electrical engineering degree than you would, for example, in a mechanical engineering degree. On the engineering side, you'll now be looking at things like electronic circuits, control systems, power, and communication systems. So we have courses like satellite communication, for example, for electrical engineers. In the Defence Force, electrical engineers work within the Army, Navy and Air Force. They have roles in communications, in satellite systems, guided weapons, radar systems and avionics systems. And our civil engineers. So civil engineers investigate, plan, design and construct the public utilities and systems that we see around us. They work in government organisations, in construction, often in large public and specialist consulting companies. So the foundations of civil engineering, again, quite different to what we've seen in mechanical and aero engineering. So you'll study things like concrete, steel and timber structures. So the different properties of these structures, the best times to use them, how to use them, the types of load they can take and so on. You'd also study things like soil mechanics, along with some maths and computer science. Civil engineering, as I said, with mechanical engineering is often concerned with very big projects. So if you study civil engineering, you'll also learn project management skills, planning skills, design skills, that give you the skills to go out into the workforce and manage very large civil engineering projects. Civil engineers work within the Army, the Air Force and the Navy. They work in airfield engineering, design, constructing facilities, roads, bridges, airfields and so on. And the last set of programs is our computing and cybersecurity programs. So these programs are 3 years at pass level with an optional 4th year at honours level. In these programs, you study things like maths, programming languages, you study data, data structures and databases, networking and cybersecurity, with some flavour of hardware, but not to the extent that you would in an electrical engineering degree. You also study things like systems analysis. So computing systems these days are not just in isolation. Computing systems sit within every aspect of our society. So they always integrate closely with people around them. So it's very important when you go into an organisation to look at a computing system that you have the ability to actually look at the systems that are already there, understand how they work, and then build on those systems to produce new systems that meet the client's needs. So computing is about both the hardware and the software, and also about the people who interact with those systems. Most modern defence systems incorporate information technology components. So students who take computing and cybersecurity can work within the Army, Air Force and Navy. The last part of any degree program, any of our 4-year degree programs, is an honours component. So this includes some specialised electives in your area of interest, and it also includes a research project. So in the research project, you have the opportunity to work one-on-one with a supervisor in their area of specialty. and you get the opportunity to design a project, set the milestones for the project, and then work through and build some sort of artifact for the project, which you then document. School of Engineering and IT has 4 strategic areas of research in technology decision making, aerospace engineering, engineering for resilience, and cybersecurity. So these are the broad areas that you might choose to do a thesis if you come study here with us at UNSW Canberra.
Thanks, Kathryn. Now what we're going to do is we're going to share a video with you from one of our 4th year engineering students about his honors thesis. And when that video is over, I'll come back and talk to you about why you should choose UNSW Canberra.
My final year thesis was conducted on the high velocity crating of cold iron. Simply this means I shot 2 different material projectiles at 2 cold iron samples at 2 kilometers per second. The context of this project is that NASA has conducted several high velocity impact missions on interstellar bodies to try and find out their internal material makeup by examining the ejected material after an impact. An example of one of these missions is NASA's Psyche mission. 16 Psyche is an asteroid located in the main belt between Jupiter and Mars, and has a similar composition to that of Earth's core. By examining the material makeup of 16 Psyche, we can start to further develop our understanding of our own planet's core. The goal of my research is to spearhead the development of more advanced research projects in the future through the creation of cooling methods that simulate the conditions in space. I also compared the impacts of the copper and aluminium projectiles under the cold conditions to measure how they performed. My findings were that the copper projectile penetrated 4 times deeper and 1.5 times wider than the aluminium. I also found that the steel target acted in a highly brittle fashion at low temperatures, and that a large steel block will stay at a low temperature for many hours with the cooling method that I've developed.
So you're pretty sure you want to be an engineer. Maybe you want to be an engineer because your parents are engineers. Maybe you want to be an engineer because you've applied to the ADF and the ADF has told you you need to be an engineer. So you want to be an engineer, but why come study with us at UNSW Canberra? UNSW Canberra is a very special educational institution here in Australia and around the world. We have a unique partnership with the Australian Defence Force where we are delivering a liberal education to trainee officers while they're pursuing their military training to begin their military careers. In addition to the trainee officers that are studying with us here at UNSW Canberra, we also have more advanced students who've been in the ADF for some time and are now coming back for a 1st or 2nd degree to change career fields. We have a number of civilian students that are sponsored by Australian Defence to study and then go into the Australian Public Service. And recently we've begun accepting Commonwealth-supported traditional civilians who are studying alongside their defence and military peers. And all of these student bodies come together in this unique environment to be able to advance what we can do in engineering. UNSW Canberra is a piece of a much larger endeavour. The University of New South Wales is one of the world's great institutions. Across the totality of the university and all of our programs, we have nearly 65,000 students and over 320,000 alumni. There are 3 campuses in Sydney and in Canberra. And UNSW has been one of the leading educators of technologists, but here in Canberra, technologists for defence, government, and industry for over 50 years. One of the unique things you get here at UNSW Canberra is the best student to staff ratio in the country. When I teach classes, as head of school, I teach a course, and my students call me Scott. You know your instructors on an individual basis in a way that you just don't get at most Australian institutions. And we have purpose-built workshops and facilities that are going to expose you to the traditional hands-on activities that engineers will do, both as practicing engineers and as engineering leaders in the Australian Defence Force. The University of New South Wales is very proud of its standing well within the top 100 of world universities through its combined undergraduate, graduate, and research endeavors across a range of disciplines. Here we see how the University of New South Wales Canberra campus sits within the Australian Capital Territory. Prominent in the front of the picture, we see the parade ground where our defense students have many of their formal military functions. To the right of screen, we have the university portion of the campus. And to the left of screen, we get on towards the military part of Duntroon Garrison. So our trainee officers will spend most of their military life on the left-hand side of this screen, and they'll spend most of their academic life on the right-hand side of the screen. The School of Engineering and IT represents approximately half of the activity that goes on this campus, and we occupy the buildings towards the top of the campus picture here in the top center of the image. UNSW Canberra has the goal of educating global leaders. Because of the nature of our students, both military and civilian, we have a unique opportunity to be able to shape the Australian and international community through the leaders that we produce in defense, government, and industry. While you're studying here, we want to instill in you a set of specialist skills, but we really want to develop your ability to work as a team, to learn and adapt to technological changes, to think and analyze problems, and solve the challenges that come up to you throughout your career. We want to produce graduates who are smart, who are balanced, they're competent in their field, but they're innovative and they show initiative to solve new challenges as they emerge. CEIT is one of 4 schools here at University of New South Wales, Canberra, and the CEIT students have a unique student life that they experience in their day-to-day existence on this campus. The typical undergraduate student profile in any one of the CEIT programs will have 24 units of credits broken up across 4 6-unit credit subjects. Here in CEIT, that means that you're going to be spending approximately 4 to 5 hours per day in class each day of the week. And each of those 6-unit credit courses has, on average, 5 contact hours between lectures, laboratories, and tutorials. Now, here in 2020, most of that material is being delivered remotely because of the circumstances that we find ourselves in. But one of the great outcomes of having to deal with this particular pandemic is that we're able to engage with educational technology in ways we haven't before. We've always prided ourselves on the small classes, face-to-face instruction. But now what we're able to do is use technology to deliver remotely those portions of the program that are best delivered remotely. Things like large lectures. Those can now be provided to students so that they consume them on their own time and in their own pace. And we can focus our time and energy and our limited physical resources into providing small group support for students. In addition to the 4 to 5 hours per day that you're going to spend in class, you're also going to have about 3 to 4 hours per day of self-study. This might be doing practice assignments, it might be studying for a class test, it might be doing group work or writing reports. And you're always going to have some amount of assignment work that you're going to have to be doing on weekends or over breaks. One of the great challenges of being a university student is that for pretty much the first time in your life, you get to make your own decisions about when you're going to do the things you need to do and when you're going to do the things that you have to do. Outside of your required attendance in lectures, you will decide when you're going to go play rugby and when you're going to get your term paper written. And that's part of the challenge that you'll be experiencing as you transition through this environment. And of course, you're going to have to balance all of that with your military training commitments if you're one of the trainee officers. The University of New South Wales has an organization called ARC, which exists to support students. It's student-run, supported by the university, but student-driven. And we have an ARC chapter here at UNSW Canberra. Traditionally, ARC has supported our postgraduate students and our research students because until very recently, we had only very small numbers of civilian students. But now that we have a growing cohort of civilian undergraduates, and in the School of Engineering and IT, we're up around 100 civilian undergraduates, making up approximately 20% of our student body, ARC is playing an increasing role in giving those civilian undergraduate students a voice in this community, both with their colleagues, their fellow classmates, and back to the school and to the university. One of the key elements that we use within CEIT to support our students' learning are our 4 supported student clubs. There are a number of clubs that run at ADFA, and if you're a trainee officer, you have the opportunity to sing in choirs or play in ensembles, play on sports teams, debate, do performances, any manner of different voluntary extracurricular activities. But there are 4 of these that the school sponsors that we encourage all of our students to be able to participate in. Looking at this screen, we'll talk briefly about each of them. The UAV Challenge team, this is a team of folks that are making autonomous air vehicles. And every 2 years, there's a competition run here in Australia, but with international participants, looking at different aspects of using UAVs to be able to solve some of the medical challenges associated with our diverse landscape. A couple of years ago, a group of students began a new club to participate in the Australian University Rocket Competition. We will now show you a video produced by the Rocket team to show you how the clubs work in the School of Engineering and IT.
My name's Andrew. I'm doing 3rd year electrical engineering, and I'm the founder and director of the Rocket team. At UNSW, we've already got the Formula SAE team and the UAV team. So we wanted to give some more options for getting involved in some engineering in a practical environment. And there's also a competition coming up that's organised by the Australian Youth Aerospace Association called the Australian Universities Rocket Competition. And we're going to be trying to compete in that, getting up to 10,000 feet next year and then getting up to 30,000 after that. The competition has a lot of reports, and there's a significant business component where we essentially need to write about what we're doing and sell that to sponsors and get sponsorship to do some more cool things. And that's where people from the business and humanities faculties can come in to help us out with that.
And when building a rocket, we need everyone with every other skill, because we're going to need someone who's going to be able to market it, someone who's going to be able to do the finances for it. We're going to need someone who's going to be able to design it, and someone who's going to be able to, someone's just going to be able to do the speaking, where someone's going to be able to be in front of the forefront of it. Nowadays, it seems like everyone is interested in high-speed vehicles, and rockets are very obviously high-speed vehicles, and it's something that's really interesting, especially if you're an aeronautical engineering student. I just want to say that rockets are pretty cool, and people should get involved.
I guess the really cool part about being on the team is everyone's starting off. It's in the early stages, so we can work out what we're doing all together, and hopefully everyone will feel really a part of it. So we launched with a local hobby group, and they have a lot of knowledge, which makes it easy for most of us who haven't done any rockets before joining the team. It's easy to come in and just launch some rockets on day 1 and see how they work. Always looking for more people, lots of capacity for more people, and yeah, 1st to 4th years, civilians, trainee officers, anyone who wants to be involved.
One of our strongest and most enduring clubs is the Formula SAE racing team. Every year, a group of 15 to 40 students from all across all of the majors at UNSW Canberra comes together to create a vehicle. But it's more than a vehicle. What they're really creating is a team. Yes, there's a car. They design the car, they build the car, they test the car, they tune the car. But there's a driver, there's maintenance, there's future cars that are going to be built for future years of the program. And so what they're really working on is a system. And the last of our sponsored club is our cybersecurity club, where our students in information technology have the opportunity to participate in hacking challenges, student competitions, and other things. And the important aspect about all of these clubs is that these clubs are tied in with what you're going to be learning in your classes as a student. And so while students from mechanical engineering might be more inclined to go into the race car team, we also have students from all of our engineering disciplines, as well as the other schools in business and humanities, who are participating in each of these clubs because of their interests and their particular skills. One of our most important programs that we run in CEIT is what we call YOWI. And YOWI stands for Young Women in Engineering. YOWI is a summer program that we run for young women in years 10 and 11 in school who are thinking about a career in science and engineering. We've been running YOWI for about 5 years now, and last year we had nearly 100 young ladies who came in and spent 3 days doing all manner of things, from rebuilding a lawnmower engine, to making polymer materials, to learning about how to make the foundation for a building. It's a unique opportunity for young women to study with each other in a safe environment with mentors who are both experienced female mentors as well as men from our staff who have designed these experiments. And we're extremely excited about the YOWI program, which has been going for several years, because now we are starting to see our first YOWI girls who are graduating from school and entering tertiary study. And out of the first cohort of YOWI girls, 5 of the 7 girls who graduated last year, year 12, who participated in YOWI, ended up pursuing STEM-related degrees, 2 of them with us here at UNSW Canberra. For more information on the YOWI program, please go to the website that you see on here. The program will run from the 13th of January in 2021, we hope, and applications will close at the end of October. Please watch the video on the YOWI program, which will be played at the end of this presentation. Let's talk now about the application process to UNSW Canberra. And I'm going to talk about the application process for each of our cohorts. If you are a prospective trainee officer who is applying through defense, it's actually a 2-stream process, and you must engage with both pieces. Hopefully, you're well on your way to engaging with the defense process, where you've talked with Defense Force recruiting, you've looked at what opportunities defense may have and how your skills will match up to those. At some point in the future, hopefully you will receive an offer from the Australian Defence Force, and that offer may tell you that you must pursue a particular degree at UNSW Canberra at ADFA. But in addition to the defense process, you must also engage with the university. So you need to be thinking about what your degree options are. Do you have a profession in the ADF that gives you flexibility? Or are you going into a profession in Air Force or Navy that requires a particular degree type? Many of our RAF students that study and see it are given a narrow set of choices, electrical or aeronautical engineering. Many of our Navy students are indicated, okay, we need you to study mechanical engineering for the careers you're going to do. So you need to look at what your degree options are, match up your chosen ADF career with those degrees, and decide and apply for the degrees through the UAC process. As we near enrollment at the beginning of next year, or whenever you're going to be entering university, you will have an ADF offer for a career and a UNSW offer for entrance. And with those 2 pieces, you're able to march onto campus in February for your year 1 familiarization training and begin your career in the Australian Defence Force and your future as a UNSW alumnus. Some of you may be aware of the Defense Civilian Undergraduate Sponsorship Scheme, or what we call DCUS. And for about 10 years, Defense has been sponsoring civilian students to do their 4-year engineering degrees at UNSW Canberra. And for the past couple of years, they've also been allowed to study our Bachelor of Computing and Cybersecurity, which is a 3-year degree as well. That is a process, an application process that is run completely by Defense. And you need to engage with the DCUS program to get your applications in for 2021 study. You will also need to apply to UNSW through the UAC process, and again, you will receive 2 offers for that. For those of you who are interested in a traditional Commonwealth-supported student under the HEX scheme, applying to UNSW Canberra looks almost like applying to any other university in the country. You will need to submit your UAC application through the online system. You need to make sure you've made contact with us in our admissions so that we are aware that you understand that you're going to be studying here at the ADFA campus and what that means in terms of studying with the defense students. But we also use a supplementary admissions scheme in the School of Engineering called FIAS. And FIAS I'll talk about in a second. This is an alternate admissions pathway for students whose entry ATAR doesn't meet the advertised guaranteed entry ATAR, but falls in the range of where we know students can be successful. And we're able to evaluate those students on a case-by-case basis, look at the subjects that they took in school, and bring them in to begin their successful careers here at UNSW. In addition to the application process and putting in all of your materials, UNSW runs a scheme that we call adjustment factors, or what we used to call bonus points. And UNSW has 3 different categories of adjustment factors that can help your entrance score and make you more competitive for admission to UNSW. The first of these schemes is known as Elite Athletes and Performers and Leaders, and these are for students who undertook significant extracurricular activities throughout their Year 11 and Year 12 careers in ways that might have had some impact on their academic performance. So examples might be state representative sport, high-level performance artists, or major leadership positions inside your school or in your community. You apply for the EAP&L program through UNSW, following the link that you see on the screen. We also have a program called HSC Plus. And HSC Plus is an automatic program that you don't need to apply for, whereby the university will look at the subjects that you took in school and how you did on them. And each of our degrees has a particular set of high school subjects that will earn HSC Plus points. Now, for those of you who aren't from New South Wales and are studying in another secondary education system, don't worry. We know how to adapt the Victorian and the Western Australian and the Queensland systems to the HSC, and these bonus points will be evaluated automatically. The last program is the Educational Access Scheme. Traditionally, the Educational Access Scheme has existed to help those students who encountered unexpected challenges in their Year 11 and 12 studies due to family reasons, due to personal or family illness, due to limited opportunity where they live. And of course, here in 2020, we find ourselves in a very strange world where many students who would not normally needed to have access to this scheme are finding themselves facing challenges associated with their schooling that they never dreamed they'd have to face. The EAS scheme is again administered through the University of New South Wales, and you can find out more information about how to apply through our admissions team. The first of these two schemes, each of the first two of these schemes allow a maximum of 5 bonus points, and the Educational Access Scheme has a maximum of 10 bonus points. Traditionally, there has been a cap of a total of 10 bonus points across these 3 schemes. So there's a cap on how many you can get as part of your application process. And that cap is being evaluated this year because of the challenges that Year 12 students are facing associated with COVID-19. So be sure to check in with the admissions team for the most up-to-date information on the adjustment factors for the entering class of 2021. Let me talk now about FIAS. University of New South Wales, we have a very high guaranteed entry ATAR. But if you don't make that guaranteed entry ATAR, it doesn't mean that you don't have an outstanding chance of making it into the University of New South Wales. The Faculty of Engineering has long had a scheme where they're able to evaluate students who fall just below that guaranteed entry cutoff, and we're able to look at the subjects that you've taken, the successes that you've had, the things that you do outside of school, and your own personal makeup to identify whether we think you have what it takes to be a successful engineer. We encourage all civilian students who are applying to UNSW Canberra to engage with the FIAS program, because if you engage with the FIAS program early, we can immediately apply that to you once ATAR scores are released in January without having to take additional steps. If you make the guaranteed entry ATAR, great. If you fall just below the guaranteed entry ATAR, then the FIAS scheme allows us to act quickly on your application and extend you an offer. And we strongly encourage students who are expecting an ATAR anywhere between maybe 80, 82, all the way up to the guaranteed entry ATAR to engage with the FIAS process. And we'll be able to process those applications when they come in at the end of the year. There will be live Q&A sessions as part of the open day, so be sure to look on the website as to where to find that information and how to ask those questions. And I look forward to engaging with many of you today, over the course of this weekend, and over the coming months and years as we look towards your studying with us here at UNSW Canberra. If you're interested in listening to some of the questions and answers from audience members at last year's Open Day, please visit the link on your screen. You'll hear questions asked by audience members that'll be answered by myself, by Kathryn, and by 2 trainee officers that were studying here at ADFA last year, Officer Cadet Sarah Flint, who's an aero engineering major, and Officer Cadet Thomas Kleinig, who is also an aero engineering major.
clean water, renewable energy, effective drug delivery, telehealth and space exploration. Engineers are vital to all of these and much more. Australia needs more engineers to shape our future. Currently, less than 13% of our engineers in Australia are female. Our aim here at Yowie is to increase the number using our philosophy of I see, therefore I do. Our Yowie program has been designed specifically to show you, the young women who are our engineering future, the exciting career that engineering can offer you. We do this through a series of fun, hands-on engineering activities, developed and led by our passionate engineering team. Over 3 days, you will learn real applications for your high school maths and science, and apply problem solving and teamwork skills to design and build an earthen dam, predict and measure the flight of a rocket, assemble gas turbine and lawnmower engines, assemble a satellite to fly a virtual mission, and program a robot and microcontroller to follow your instructions. More than this, you will join a number of girls like you with an interest in maths and science. Together, you will learn where this interest can take you and how you can contribute to solving Australia and indeed the world's engineering problems. You will hear from and speak to amazing professional engineers and women currently studying engineering. Girls, let's talk engineering.